Our next speaker is Brasseur from Certech, and she'll talk about some odor compounds in recycled material.
Thank you. So good morning, everybody. So yes, today I will show you a few examples how multidimensional techniques are very important for the characterization of odorous compounds, and especially when emitted from materials. Just to start, a few words on Certech. We are a center located in Belgium. We work as a R&D partner and supplier of analytical and technological services for industry, mainly in chemistry. We work in different activities such as environment quality monitoring, development of material, optimization of process, from small scales to a large scale implementation, and all are covered by advanced characterization platform. A request that we often have is the characterization of the odor. So it's very difficult topics. Everybody has his own way of description, his own intensity. You can try to rely on database and literature, but it's known that some compounds can have very close chemical structure but produce very different odors, so it's difficult to guess. You have an effect of the matrix to take into account, and also the component can interact and produce different odor in mixtures. There is a nice tool to, in fact, evaluate the odor correlation with chemistry. So at the end of the GC separation, you have a dual detection, a sniffing port, olfactometry port, and a detector. There are different challenges. So first, the odor description analysis. You need a standardization. You need to use chemicals and a normalized scale. The instrument is not only buying and installing the instrument, you have to think about the environment. You don't want to have pollution from the air, from odor. You cannot put the instrument in the middle of the lab, crowded with a lot of people passing around, because the exercise of sniffing odor analysis is very difficult. So you need also to think about that. There is a difference between aroma sample, what I mean is samples that are made to smell like food, fragrances, and material sample. You are not trained to the same odor. In material, you will be facing like styrene, phenol, fish, solvent. So not the fancy odor that you could evaluate yesterday at the beer tasting. In material, especially, you will focus on VOC when you compare or evaluate sample, but it's always happening at the threshold, at the background, so it's always a very low concentration. The nose is very sensitive, so you need to compete also with the detector. And if you don't know what you're looking for, of course, mass spectrometry is the best detector, but it needs sensitivity. And in some samples, such as polymer like polypropylene, high-density polyethylene, you have a lot of oligomeric hydrocarbon released by the matrix, so the chromatography is very complex, and it's even more with the recycled materials. This is an example of data that we produce. So we have two types of instruments coupled to a quadrupole or coupled to a time-of-flight mass spectrometer. The panelists, they are trained every week. Their performance are recorded. They are able to provide description and intensity on a scale, specific normalized scales. And analysis is done continuously on a chromatographic current, which means 45 minutes. So it's really a tough exercise. And you can see you have a lot of odor detected. So what we do as a first start is to highlight the individual odor detected that can be correlated to the global odor perceived. And you can also focus on the highest intensity. For the sampling, we want to concentrate as much as possible. We use custom Tedlar bag, which allow us to evaluate heterogeneous material, so big part, a lot of quantity, gentle conditioning. What is also important is that you can evaluate the global odor before sampling, because there is no need to do an advanced characterization with the sniffing olfactometry MS if you don't have a significant odor. And then we collect the hair on 10x. We have different instruments equipped with thermal desorption, so we can have a versatile technique. This is an example of chromatogram obtained for HDPE, so polyethylene sample. As you can see, it's very loaded, very saturating. Some could say, oh, the resolution is really not good. But this is really important to detect the odor. So in this case, there was more contamination, like a problem. The intensity was not so high. It's on a scale from 1 to 5. 2 is quite okay. But there was really a specific odor. And among all the odor perceived during the analysis, at least the specific odor was detected in a specific zone, which means you can see if you can detect it with the detector, the mass spectrometer, but if you cannot, at least you have the information and you know where to look for. There are so many different techniques for concentration of COV, so of course we wanted to evaluate some. So we tested the headspace trap and the high capacity sorptive extraction. Both are very interesting. You can enhance with a few optimizations that we tested to have a good intensity. And with headspace trap, you need to eat, which can be interesting if there are, for example, an odor issue during a process. The customer wants to eat also the material for the testing. The iSorb is also interesting to stay at quite room temperature and have a good sensitivity. For example, to evaluate the odor at the opening of a pellet's bag of polymer. But even if you can increase the sensitivity, there is still improvement to do compared to our method, because as the last example, we could not detect the specific odor. The test was repeated several times, so it's not that the panelists missed the odor, it's really that it was not enough concentrated. So if you compare, in this case, with a sample that are obviously made to smell, you can see that with just a simple sampling of VOC, you have a quite good resolved chromatogram, very simple. Many of the compounds are related to odor perceived, a lot of odor perceived, and a quite high intensity. If you compare the intensity, the different run, but just to show you the scales, when you compare to materials, it's even if the intensity is higher, the concentration higher, still not enough to have a good characterization of the different odor perceived. So this is some testing on polypropylene. As you can see, you can increase the intensity. You have a light VOC detected, which is also very interesting. But still not so much odor, so there are still optimization to test. But for example, with recycling, this is one very emissive. So we could detect a lot of compounds, a lot of odor. In fact, for our method, we had to decrease the loading parameter because this one was really, really emissive. You have a lot of odor detected in the first part, but also in the second part, where the coelution are very high. You have a lot of hydrocarbon isomer. So there are a lot of information, but you need to find what could be the odorous compound. So this is where the multidimensional chromatography can be very helpful. So the same sample now you can see in 2D analysis, very loaded. So on the top of the chromatogram you have this high amount of oligomeric hydrocarbons, but at least with 2D you have the possibility and the chance to detect what is behind and hidden. It's very loaded, so we have a dual detection FID mass spectrometry. FID is always important to have a good evaluation of the concentration range in your sample. But in that case, what I really want is to overload, and you can do that because you have two-dimensional. And with mass spectrometry, you will have much more information and try to find the trace level compounds. If you compare the sample before and after a specific process applied to reduce the odor, when you see the profiles, it's really difficult to evaluate the differences. If you run some software on this big oligomeric part, I don't know what it will end. It will probably freeze, but at least you can draw some region and focus on specific region. And also you can use some filters, demonstrated previously. In this case, for example, there was an effect not really on the global odor, but on some description. So there were some roasted fatty notes that were perceived, and after the process, it disappears. So at least there is an information, and then you can use a specific filter to find some information among the huge number of data produced. Fatty notes is associated to diketones compounds. So if you have high resolution, you can use the signal, the accurate signal, you can reconstruct the specific signal from carbonyl. So the specific fragment that you will have typically on a carbonyl mass spectra. And you can at least see if there is in fact an impact on this type of compounds. You can use other type of filtering. For example, the roasted note can be associated to pyridines, and you can just use library search standard result and filter and get to the interesting information. In this case, you see, in fact, an effect, not only in the number, but it's always nice to check at the 1D view. In this case, you can much more see the difference also in intensity. Other different type of filter you can use, for example, nitrogen, and easily highlight differences. Another example, this one is a polypropylene sample with a very high odor intensity, 4, and it was a specific odor. So it could be related to thiophene. So it's interesting to search for thiophene in the sample. So if you take this example of methyl thiophene, it's characterized by the 97 ions. But 97 can also correspond to hydrocarbons. And as we have a lot of hydrocarbon in the sample, if you reconstruct the mass on nominal number for the sample, you have also the contribution of the hydrocarbon. If you have 2D, you know to locate the hydrocarbon on the top of the chromatogram, and you know that the compounds of interest will be on the second part. But if you use, and so you see in 1D, it's really still a complex sample. But then if you reconstruct on the specific masses, you can highlight and take the advantage of the sensitivity. You can't use the retention time if you have standard, but it's always good to confirm with the signal. So if you see again the 1D, if you perform the sniffing and then you combine to high resolution, then you can really say, even if you say I detected the odor at the retention time, it's always better to really prove and show the signal. Last example, yeah, you could get some false positive just by looking at the library standards, especially, for example, you are looking for thiophenes, and how convenient the screening found some thiophene, exactly what you're looking for. If you have the 2D, you can in fact exclude maybe by positive by knowing where the compounds are eluting. In this case, it was in the hydrocarbon area. So you could also say, okay, no, it's not possible. But when you have high resolution, you can easily and quickly exclude false positive and avoid to report wrong results. So with this, just to summarize, there are different steps where you can work on, but it's very important to increase the sensitivity, especially if you want to compete with the sensitivity of the human nose. And GC or multidimensional technique, also high resolution as an additional dimension, are very useful to at least have a chance to find the guilty compounds. So thank you for your attention.